Welcome to Chalk and Code,
where the science of learning meets modern technology.
We're bringing together entrepreneurs, product leaders, researchers, and advocates
to spark ideas, challenge assumptions, and shape the future of learning. Welcome to Chalk and Code. Today's guest is Tyler Menezes, CEO of CodeDay. CodeDay is a nonprofit organization that provides welcoming and diverse opportunities for underserved students to explore a future in technology, primarily through its signature 24-hour coding events and its virtual internship program, CodeDay Labs. Tyler joins us today to discuss his journey as a venture-backed startup founder and a nonprofit CEO, the power of experiential learning to diversify the tech pipeline, and how CodeDay is using data and research to scale computer science access. Thank you for joining us, Tyler.
Thank you so much for having me. I'm really excited to be here.
It is a delight to have you here as our guest. So let's start with just the basics about your background and how you started and how you landed at CodeDay.
Sure. Yeah. So I very early on decided to do the typical Silicon Valley startup path, which was drop out of college and move to the Bay Area. I went through Y Combinator, which is a great startup accelerator program. They funded a lot of really successful companies like Dropbox or Reddit. And my batch was actually Clever as far as ed tech companies go. I think that's a pretty big one. Did the whole Silicon Valley thing, moved to San Francisco, raised $1 million, lost most of it, shut down our company. But throughout all of that, I was actually also volunteering for this nonprofit that some friends and I had started when we were in high school that was focused on helping students learn how to build real stuff and take all the stuff that they were learning in school and not just use it for passing the test, but use it to do cool stuff. And so when that startup decided we were going to close that down and return what was left to the investors, I was kind of thinking about what was next, and I was just very passionate about this area. So I started working on that, less of a part-time thing and more of a full-time thing, and eventually became my full-time job, which it has been for now the last 10 years.
That's fantastic. So my understanding of CodeDay is that you focus on students who really don't necessarily have a prior interest in coding. Is that right?
That's where we started, and I think it's changing a little bit now. But where we started was we realized that there were a lot of students who were now being forced to take computer science classes. In the same way that math is required now, a lot of places require computer science, and we realized that a lot of students just didn't really see the fun in it. And so we sort of saw an opportunity there to be able to go in and say, hey, you can use this as a medium of creativity. You can use this as a way to shape your world. You can, if you want to become a carpenter, you have to invest in a bunch of tools and a bunch of wood. But if you want to build a website, you really just need a computer. And even if you don't have one yourself, you can go to a library and use one. And then you could start the next Facebook. So yeah, a lot of our early work has been around those students who don't have a lot of interest, and how can we get them to see that this is actually really fun and cool and exciting.
So if we're focused largely on the students, one of the questions that we often ask on the podcast is for folks to describe where their product or their service or their offering kind of fits along a continuum. If you think of education as being, or ed tech as having systems that support the system of education, like the school districts or the educational process itself, and on one end, and then at the other end of that continuum, you have products or services that are really designed to spark learning at the individual level. It's not necessarily kind of focused on the system. Is it fair to say that CodeDay kind of is really focused on the individual learner?
We are. I will say that we started off entirely focused on the individual learner and entirely focused on what did the students need, and to the exclusion of caring at all about what the educational system needed. And I think over time we've moved a little bit more toward the educational system side of things, because it allows us to do things at a much greater scale. we still are very focused on, we always want to do right by the students. We always want to make sure that we're building programs that are really going to serve the students first and foremost. But we've become a little bit less stuck in our ways there, and a little bit more willing to compromise, a couple small features of it if it means that it works much more easily within the bigger system, and we can reach a lot more students that way.
So how do you kind of integrate into an ecosystem like a K-12 school district?
Yeah, that's a great question. So we started out, like I was saying, we started out entirely focused on the individual students, and what we were doing was basically what is now known as hackathons. When we started this, no one knew what a hackathon was, the students get together for a weekend and they build something cool, and a lot of students would never go to a coding thing normally. They wouldn't go to a workshop. They wouldn't really choose to go to a class. And they wouldn't really go to a hackathon, which is partially why we don't really use that word. But, we would get them, we would reach out to all of these different folks who teach creative classes, art, music, things like that. And we would get them together for a weekend, and we would say, hey, do you want to make video games? Do you want to do music for a video game? Do you want to do the artwork for a video game? And a lot of students would say, yeah, I would love to. I love video games. It's very popular with the kids. And so we get them together, and then it's like, well, you do the art for the video game, but we also need to make the game. And we're not coding, we're not capital C coding, we're just making video games. And then, sort of throughout the course of one of these events, the students come to realize, slowly they come to realize that they are actually coding. And then they also come to realize that it's fun and creative and interesting. And that's sort of where we started. And that was great. And the outcomes from that were amazing. But, it's hard to scale that without building it a little bit more into a traditional education system. So over time, we've become a little bit more flexible in terms of what the events look like. But they used to be 24 hours, noon to noon, Saturday to Sunday. But for a lot of students, especially outside the US, we've noticed, it's a lot of schools are not really willing to promote something that's like an overnight activity, or a lot of parents are not willing to allow their kids to go to that. Also, we've worked with a lot of teachers that we've met that have been very excited about this and wanted to bring some of this back into the classroom. And so figuring out what the tie-ins are there. Basically, we started out with this project that the students really love. And then we sort of started to figure out, okay, well, what are the through lines back into the traditional education system? And what are the ways that they can use what the students are learning from this? What are the ways that we can describe what we're doing in a way that teachers understand what the benefits are that students are getting out of this? And all of those sort of little pieces that are really more of the integration pieces.
Okay. So it sounds like you're pursuing both paths, that sometimes you go into the organization, or maybe you're introduced into the organization, the local education agency. And go from there. And other times it's through teachers picking up what they can learn about CodeDay and bringing it into the classroom on their own.
Yeah, exactly. Definitely, it goes both ways. We get the students from the schools, and then a lot of times the schools realize how exciting this is for the students, and seeing that, and they wonder how we can, how they can take some of that back in. And I'll give you an example of this. A school that was participating in CodeDay for a long time, they weren't really sure what to make of it from the first one. I remember, we got a bunch of emails and a bunch of calls from the teacher there, just wanting all their questions answered, because there's a lot of unknowns about bringing some students to this 24-hour event. And then, after they went to 2 or 3 of these, they started to love it so much that they ended up adding a class to their school that basically could be taken as an art credit or a computer science credit. And the idea was to bring together the creatives and the coders, and they all learn a little bit from each other. And then it was sort of a projects-based class. So for the entire semester, they would be making something with both the creativity and the code, which was super cool and unique.
They figured out how to give the student credit for the work so that it showed up on a transcript. And you said it wound up being like an art class?
They could take it as an art or a computer science class. Yeah, it was a sort of unique collaboration between the computer science teacher and the art teacher.
Fascinating.
Yeah, so it goes both ways. I think we've learned a lot from traditional education system. They've learned a lot from us. I will say for us in particular, we tend to work more bottom up than top down. We work a lot with the individual teachers, the principals at a school, and usually word sort of makes its way to the district level versus us going into a city and partnering directly with the school district or something. We work a lot with the individual teachers.
Okay, so they're pulling you in.
We do a lot of email, just cold emails, cold phone calls, that sort of thing. I think there is a learning curve. There's a lot that we've learned over the years on how to sell this to people. Again, when we started, we were just like, well, what do students want? And it has been years of us learning that we need to also make sure that we're explaining it in a way that the education system understands what it is that we're doing. That's been a learning curve on our side. But then from the teacher's perspective, I think there is a learning curve because a school system traditionally is used to this idea of, at the end of the lesson, students are going to be able to ... right? That's the way you structure things. There's specific educational outcomes from everything. And for us, for the students who come in, we say, what do the students want to make? What app do they want to make? And then what are the tools that are going to get them there? So I can't promise you that if a student comes into CodeDay that they're going to be able to learn about linked lists, as a CS thing, right? I can't promise you that they're going to be able to learn about like a for loop. Every student is going to learn their own individual things. But what I can say is their mindset is going to shift as to how to use this. I can say that their motivation is going to increase, on average. And I can say that the students are going to learn more of the independent problem solving and these sort of like higher level skills that are really hard to measure on a standardized test, but are super, super valuable in terms of their future education and in terms of what they're going to do in the world after they graduate.
Right.
But I think for teachers, it's sometimes hard for them to come around to that line of thinking, having spent so long thinking about the individual lessons.
Right. Because the lesson has to be assigned to or aligned to a particular standard, which kind of rolls up to other standards and gets tested. That was actually one of the questions that I wanted to ask you about, because when I was reading up on CodeDay and kind of the regular 24-hour events and the mentoring, it did sound like it was structured largely for the student to explore. So to start with the student's desire to do a particular thing or tackle a particular topic. The key that you were wanting them to take away was more independence and more understanding of how a programmer or an engineer would solve a problem in the real world. So there's enough flexibility around it to be really well tailored for the individual, but had kind of this built-in tension with, say, an educational system's kind of process for teaching standards and skills that build on one another. And that was, you answered that question. So I want to move on to the next one, which is there a tie-in between what you're doing and something like micro-credentials or preparing people for, for a work environment in a kind of a more structured fashion?
Yeah, absolutely. And I always like to say for computer scientists, this gold standard for sort of a micro-credential for a computer scientist is open source contributions. For anyone who hasn't heard the term open source, that a lot of the software we use every day is built by unpaid volunteers for free on the internet. And all of the software that's this open source software is just freely available, and anyone is invited to contribute to it. There's sort of a verification process, but anyone's invited to contribute to it, and it's all public what you have contributed. And so it's really helpful for our students. In the end, our ultimate goal after our high school hackathon program that I was just talking about, and after some of the stuff we do with college students specifically, our ultimate goal is we want the students to be able to make these open source contributions, because when employers see those on a resume, they know that the students are workforce ready. And those are something that they can just verify themselves.
So even deeper than the micro-credential itself, it's a work product that is demonstratable.
Exactly. And it's a small individual work product that, one of these open source contributions might be as little as 2 lines of code changed. So it really is truly quite small. but it demonstrates very specific things. And, we've done a lot of work with employers to understand what are the things that they want to see demonstrated. And the traditional, education system, a lot of those things that they will demonstrate are going to be very specific domain knowledge. This is in computer science, it would be something like, do you know how to use an API? Or, in biology, it might be something like, do you know how to do like a PCR? Or, there's every field has their own specific skills that need to be demonstrated. But there are also these higher level things that we hear from employers that they're looking for. And those are the things that we've found that these open source contributions for computer science and some of the related technical fields, that they can demonstrate those higher level things like, problem solving.
You gave a talk at FOSSE 2025. I'm gonna read the title, and you tell me if this was correct. Nurturing the next generation of open source contributors.
Mm-hmm.
Okay.
Yeah.
That was about 2 months ago. Yeah, you had described in there in some of your talk that you were speaking to hiring managers, and there were some certain things that they were emphasizing that they were looking for in college grads, and that you were and through your work you were trying to help. And I would you talk about that connection between CodeDay and what you were describing there in that talk?
Yeah, absolutely. I think, and we actually even have some more recent data that I'd be happy to share with you today too. But basically, when we actually talk to the companies, what they're emphasizing more than anything is independence. They want people who can work independently. And in software, and I think that this is true at least in many STEM fields, but also just many knowledge fields in general, there's this perception that students will graduate from college, and the employers know that you graduate with an undergraduate degree, you come work for our company, we're really not going to get any productive work out of you for the first year. From employers, there's this understanding that really the first year that you are employed by them is actually still kind of just traditional education in some sense. You're learning a bunch of stuff on the job that you didn't learn in school. Students don't know this. It's kind of a interesting thing. A lot of students expect that when they graduate, they're going to be fully prepared for the jobs. And when they find out they're not, they're sort of unhappy with that. But that has been a perception for employers. And what we found is that over the last 3-4 years, since AI has taken off, a lot of the things that employers, the senior level employees at these companies would be assigning to these brand new grad employees, the tasks that they would give to those new grads to help train them on how to do these more complicated things, those tasks are just being given to AI. You can spend a bunch of time providing all of these details on what someone needs to do and give it to a new grad, and they'll spend a couple weeks and give you something that's not quite right, and then you'll go back and give them some more feedback, or you can just give it to an AI and it'll do it in 10 minutes. So that's been a problem that we've seen from our students and from our employers, is that they're not willing to invest that year of time into training these new graduates anymore. And so what we did was we went to these employers and we said, well, what is it that the mid to senior level employees that you're still hiring, what is it that they have that these new grads don't have? And a lot of that is basically the ability to work independently. And it's not the specific skills. The employers all said that the students have the specific skills. They have the specific technical skills, the sort of things that students teach that schools teach to students. What they're missing were, this is actually more recent data, curiosity, initiative, communication, product sense, and problem solving. Those were 5 of the 6 things that employers said that students needed to have to really be at that mid-level, senior level employee that they really want to hire. And the 6th one is domain knowledge, and that's the stuff that the traditional education system teaches. So 5 out of the 6 things that they're looking for are things that are very difficult to teach in a traditional classroom because they don't really have an easy way to measure them. It's hard to generate them in general. Like it's hard to teach curiosity when you're doing, worksheets and tests and things like that. It's hard to map them into the traditional classroom. But those are the things that students need, it seems like now, to get a job. And so that's really what we've been focusing on, especially for the people who finish CodeDay events, those hackathons, and they go off to college. How can we start to teach more and more of these things?
Okay, I see a very clear connection. Oh, thank you. That was perfect. I have noticed some of my colleagues who are engineers going through boot camps, and this is especially over the last, say, 5 to 10 years, going to boot camps, doing some kind of capstone project, getting work, entry-level work, and then working their way up. And then at some point, if they want to go farther, or maybe sometimes just for curiosity, they will go and start a CS program, kind of a traditional education after they have learned a certain point. Are you seeing anything like that as well?
Yeah, I think so. I think that one of the really interesting things there is that the sort of experience that a bootcamp would provide, like you said, it's very focused on projects, and that's almost completely, orthogonal to the stuff that you're learning in a traditional school. So in a traditional school, you're learning all of those very specific skills, and then in a bootcamp program, you're learning a lot of the how to work in a team, how to figure out the answer to a problem when you haven't seen it before. All of those sort of things. And so they're kind of just two different sets of skills. And what we've seen is a lot of people who have the ability to do those projects, they're capable of learning things, but they oftentimes find, it would actually be really nice to have a traditional education to teach me all of these specific the specific domain knowledge that schools are traditionally done. But then, we've seen the exact same thing on the opposite direction, which is now increasingly we see a lot of students graduating with a traditional computer science degree who are saying, I have all of this knowledge, but I don't know how to do anything. And so no one will hire me. And so they're looking for more of like that, again, more like that bootcamp model. And I think what we have really tried to do, and our vision for how this can all work together, is we need to get more of the projects piece into the traditional education system, both throughout that, the 4-year degree. And we started out as like a senior capstone level stuff, and we've just moved backwards in the program. So now it's juniors and sophomores who are doing it. And, maybe even all the way down to high schools and middle schools, we should be having this sort of project-based learning as a part of the educational system, or at least as something that's on top of, or next to the traditional education system, so that students are getting both throughout the entire thing, because it seems like that's what a lot of students need nowadays.
You had also mentioned in that same presentation about that the process you had described was, if I remember this right, the title of the slide was "Unemployment, or underemployment rather, is sticky," and the chart was like a Sankey graph where it starts off. It looks like here's the point of graduation, and then you kind of have two groups of people who are either getting employed or not getting employed in that first year, and how it affects the rest of or the next several years of their career, or trying to get started in a career. You described that really well there, and I've been wondering since I saw that, how do we fix that? How do we close that gap between getting the degree and getting to employment? And whether or not it's, things like CodeDay, if it's more internships like you described.
Yeah, absolutely. And I think that was from data from the Burning Glass Institute. Just to kind of summarize it, I think you did a pretty good job, but to give you the numbers, it's something like 52% of college graduates end up in a job that is not a college level job. And they might make a little bit more money than a high school graduate, but not much. And of those 52%, if you look at them then 5 years down the line, 45% are still in underemployed in a job that doesn't require a college degree. And then you look at them 10 years down the line, and 45% of them still end up in a job that's doesn't require a college degree. So most of the students who are graduating, if they don't get a job right out of school, they're very likely to stay underemployed. There's very little movement between the groups. And again, if anyone's interested to see the whole diagram, Burning Glass Institute, if you search for Burning Glass Institute underemployment, you can find the chart that you're talking about. So we think one of the most important things for that is just, we really need to close the skills gap, the knowledge gap, the ability gap, whatever you want to call it. We need to close that gap between when a student walks out of their undergraduate with their degree in hand, and they walk across the street and they go to a company and they say, I'm looking for a job. Obviously, that's not really how it works, but you can sort of imagine it this way. Like there's a gap in what they know. And in the technology industry, we can quantify that pretty well. You've probably heard that there have been a lot of layoffs in the tech industry, and you may have also heard it's really difficult for students to get jobs. There was a New York Times article recently that was saying, basically the title was something like, forget the, $165K a year starting salaries, new grads in computer science are looking for work at Chipotle. And so we have the data, and the data shows that if you look at hiring in the computer science field from 2019 to 2024, for people who are new grads, 0 to 1 years of experience, hiring is down 25 to 50%. But if you look at people who are mid to senior level employees, hiring is up 25 to 50%. It actually pretty close to counters it out. So if you look at just the aggregate numbers, and you'll see that tech hiring is not doing that bad. The problem is new grads can't get jobs anymore. That's the skills gap, right? That is saying that basically a quarter to half of our graduates are not at the level that companies are willing to hire them right now. And you can make an argument that, that's because the company is, they should be investing more in the talent workforce and new grad hiring. But you can also make the argument that colleges need to be preparing them for something differently now, right? Like we're seeing if employers aren't hiring people with the degree, that might mean that the degree is not as valuable as it used to be, and that it needs to evolve. And so that's kind of, that's our take on it, is we need to make sure that the students who are graduating with a CS degree, that degree means that they have the skills to go over into industry and be able to contribute productively from day one or pretty close to day one. And that's about moving them up to those skills that the mid-level and senior level engineers have.
Can we wrap back around to the topic of AI for a moment, and try and connect this issue that we've been talking about with AI and how often we kind of read, I don't know how true it is, but how often we read that AI, something like Claude, is good enough to be like a first year employee. And that also is kind of exacerbating this problem that we're describing here. And then see if we can't wrap that into the mentorship that people can get with CodeDay.
Yeah, absolutely. And I want to say, first of all, I think a lot of the stuff that you hear about AI coming for jobs is starting with computer science. And the reason for that is actually open source software that I mentioned. There's a lot of code that's available for free online. And the people who make Claude are programmers. The people who made ChatGPT are programmers. And they trained it on all of this code that's already out there. And so it's very good at doing tech jobs. But I think it's, it's kind of the terms bellwether, right? Like it's kind of like the coding industry is where a lot of industries are probably going to be in 5 to 10 years. So I think everyone should be concerned about AI to some extent and what it means for new graduates. And yeah, I mean, you're right. There's a lot of people saying that AI is replacing new grads. And that's what we've seen. That's been my own experience. I still write code for fun sometimes, and that's been my own experience. There are things that we've done even as sort of side projects at CodeDay, because we write a lot of software ourselves, and there are things that I would have had to hire an intern or like a new grad for and give them 6 months and have them build it. And now it's, I can give them the same level of detail I would have given to those folks. I can just give it to an AI and it'll do a pretty good job a lot of the time at building what I need. The challenging thing is having someone like me who's able to give that level of detail. And those are the skills that are a lot safer and seem to last a lot longer. And those are the things that we think are going to be relevant well into the future. And I think that's true for other fields as well. As AI gets better at things like developing new pharmaceutical drugs, or biology, or whatever other field you want to look at, you're always going to need, or maybe I shouldn't say always, but for the foreseeable future, you're going to need those mid to senior level people who understand what needs to be built. The challenge is just that they're getting better and better at doing those entry level jobs. And obviously the problem then is, where do the mid and senior level people come from if those entry level jobs aren't available? And that's kind of why we're saying, really, like, kind of the new entry level is like mid level to some extent now. We need to give them some of those skills before they graduate, or they end up in that trap of being underemployed. And again, that's what we're seeing right now in computer science, and it's probably going to just expand to more fields as AI tools get better.
So how is the mentor program at CodeDay and not an alternative, but a way to mitigate that? I mean, if we have more experienced people kind of teaching, younger entries into computer science, younger people, or new entry people who are newly introduced into CS, can the mentor be that bridge? I hesitate to describe it as a guild, but that's kind of what that was the image that came to mind. More experienced person sharing information with a younger person about how you would go about solving a problem, and teaching not just here is the answer that an AI might give you, versus here is how you arrive at, say, multiple options, and how you might choose a particular answer.
Yeah, absolutely. And I think that's a lot of what we're trying to do, is that the sort of sharing those models of thinking, right? Sharing how we problem solve, think creatively, how we have product sense, right? Thinking about the end user. All of those are thinking models. They're not really easy to teach in a traditional way. You probably could, and I'd love to see more research on that, but they're not as easy to teach in a traditional way. And I think mentorship is a great way to do it. So the way that we've structured our mentorship, always, all high school programs and the college open source programs that we've been talking about recently, our mentors don't know the answer to anything that we're giving them. That's very intentional. Sometimes we have mentors who have experience with a particular open source project. They've contributed to it before, and we actually won't assign them to mentor for that project. We'll assign them to mentor for a different project. Yeah. And the benefit to that is, when a student then comes to their meeting with their mentor, and they have these meetings once a week for anywhere from 4 weeks to 12 weeks, when they're working on these contributions, and they'll say, here's what I think we're working on, in my own words. Here's what I think this is asking me to do, this bug that we're trying to solve. And the mentor will say, yeah, I don't know either, but here's how I would try to figure out if you're right about that. Like, I would go and take a look at the project description, and does this project description, it sounds like maybe the project is doing something slightly different from the way that you're talking about it. So let's try to figure that out. Or they'll say, they get further on into trying to solve a bug in one of these open source projects that they've been assigned to. To give you an example of one of these, it's like the Firefox web browser, the Chrome web browser that everyone uses. Like, we've had students contribute to those. Let's say they're trying to solve a specific bug on Chrome, right? They go in and they say, here's some potential places in the code base that I think might be relevant. That's one of the things we have them do. And they present it to the mentor. And the mentor will say, I don't know either. And this code base is 10,000, 20,000 files. So it's huge. So here's how I would narrow it down. And very authentically, because they don't know the answer. They can't, we're not asking them to pretend that they don't know how to do it. They genuinely don't know how to do it. And so the students actually sort of work with them in the same way that they would at a company. If you're a new grad at a company, you are solving a truly new problem that no one knows how to solve, and you're partnering in some sense. You're getting mentorship from a more experienced person on your team who also doesn't know how to solve that problem, but probably has some context built up on how they could approach it. And we've sort of, we've created these artificial situations where a mentor for high school hackathon programs, a student is coming in and saying, I want to build a video game that does X, Y, and Z. And the mentor is like, I've never built a video game that does X, Y, and Z before, but maybe here's how I would think about it. And for the college programs, they're saying, I want to solve this really complex technical problem that's causing bugs for 5% of users. And the mentor is saying, I've never seen this code before in my life. Here's how I would go about it. And it turns out that actually really transfers those models of thinking really well.
Are there certain sizes certain size groups that the mentors are assigned? Is there a minimum and a maximum?
Yeah, we usually do groups of 2 to 4. We have found that a group of 2 is kind of ideal. Because it gives us, we don't want to go smaller than 2 because having someone else to talk with and bounce ideas off of is actually really helpful for the students. Our mentors are really busy. They've committed like an hour a week. The students, on the other hand, are spending 10 to 30 hours a week. So they're spending a lot more time. It's helpful to have someone else to bounce ideas off of.
Okay.
We don't go above 4. Our data just seems to show that like a group of 4, there's just a lot of communication overhead. And that tends to make things more complicated. So ideally 2, but just in terms of the sort of unit economics of it, it tends to be easier if we do groups of like 3 to 4.
Are they adopting some of the practices that we have in software development, where one person will drive, one person will be a passenger, and they'll have a conversation? Do that?
Yeah, absolutely. Pair programming. Yeah, yep. That's a very common thing that our students will do. We also see, though, a lot of it is just these sort of informal conversations that happen on chat. We actually have the students do standups, another thing that's super common in the tech industry. We have them do them asynchronously, so it sort of is posted twice a week to a Slack channel. And, quite often the students will see that their teammate posted something else in a stand-up and they'll say, oh yeah, I know how to solve that. Getting the code running is a good example of this. It's often very difficult to get your code running for the first time. The students might spend an entire week just getting the project to run properly on their computer. And quite often one teammate will figure it out before the other ones. And then, someone will post about a problem they're having in their Slack and they'll say, oh yeah, I already solved that. Here's how you fix it. So that's been really helpful too.
Wow. Tell me, Tyler, what kind of challenges you're facing now and that you are preparing for, that you see coming down the pike.
I think that for us as an organization, one of the big challenges is just trying to make this more of a structural thing in education, and just trying to make this not just a one-off thing. We started off, like I said, running events, right? And it was once a weekend, we would do, or sorry, once a quarter on a specific weekend, we would do like 3-day holiday weekends in the US, and we would do it simultaneously all around the US. And that was very easy for us to do because, you just ship out a bunch of boxes with the supplies and everything happens on the same day. And that's how we started out with this college level programs too. We started off as a one-time thing. It was like just over the summer originally. Now we're doing it every month during the school year. But we really have realized that doing this once is helpful, and it makes maybe 40% of the difference that students need. But doing it as a sustained change to the way that education is delivered is what is really in the long term going to be needed. And the students that have done best through our programs are the ones who did this once in their sophomore year. And then they actually got so excited that they kept contributing to these projects. And while they were going through school and they were learning these skills in school, they were also applying the things that they were learning to these projects and developing these higher level skills at the same time. And those students are the ones that have every employer who wants to hire them. And that's what we're now trying to do. We're starting this thing called an open source fellowship, where the students who finish these programs are actually able to continue to get some support from us and some guidance from us and some structure from us. And a lot of automated tools and software we've built along the way, so that they can continue to contribute to these projects in a structured way while they're going through school, so that by the time that they're done, they don't just have one open source contribution to point to on their resume and say, look at what I'm able to do. They have 50, and it's a project that all these employers have heard of, and they're, going to conferences maybe because some of our students have been invited to speak at conferences based on these contributions, and all of these sort of things that come out of the sustained engagement in this project-based learning.
Okay. Now, You've described. You mentioned a moment ago it was the sophomore who tended to be successful. You've kind of described you've used statistics and some information, some data throughout our conversation, and I found myself wondering, how are you measuring for yourself and for CodeDay both the level of engagement that you're getting and the results, the efficacy of what you're doing? And
Yeah,
I'm
absolutely.
sure you've got numbers.
Yeah, so the long-term efficacy, I think, is the easier thing to measure. It's how many students get jobs. I should
Okay.
say, it's somewhat challenging to measure because students don't always give us the answers. We have some work where we're going out and looking at their LinkedIn's. Yeah, we'll send them surveys, but a lot of people don't respond. But in theory, that's what we're looking for. And how does that compare to their peers? And how does that compare to to what it used to be? We also have some numbers on, we get students to give us every month as a part of one of our partnerships. We have students every month give us, how many jobs did you apply for? How many interviews did you get? And how many offers did you get? And that's kind of a pipeline. And that gives us short-term data. How many applications is a student having to make to get an interview is a really good short-term bit of data on how good their resume is. And then, in the really short term, in the moment while we're running our program, we have a lot of sort of metrics and instrumentation that we're tracking. Tons and tons of different things. One of my favorites is the standups that I mentioned that we have students do. Every single stand-up we have, it goes through an AI tool that actually classifies it as, is it vague or specific? And then if it is specific, is it roughly the amount of work we would expect? Does it seem like it's the amount of work that we would expect? And then also, does it change over time? Like, are they saying the same thing every single stand-up?
Right.
And we published a paper on this last year, I think in 2024, where we showed that this was actually very, very effective in not just identifying how well students are doing, but finding the students that are struggling and helping them. Because the students who are regularly submitting the same vague stand-ups day in and day out, they probably are struggling with something, and they're struggling to write about what they've done because they don't know what to do. So there's a lot of those sort of things that we've built into our programs throughout the entire thing to try to get a handle of, at this exact moment, how is this exact student doing? And it's not for grading purposes. It's for the purposes of helping us make sure that their outcomes are better by identifying the problems earlier.
Well, as we wrap up, I'm going to ask you the question that we ask every guest, and that is, what are we not talking about or thinking about in education and technology that we should be? What are we missing?
Yeah, I think that the big problem right now is what is happening to entry-level jobs. And when people talk about AI, a lot of people are talking about how AI is impacting education the way that it's traditionally been delivered. Students cheating with AI. Should students be using AI at all, or should they be working completely independently? Like, how do we draw that line? That sort of thing. There's a lot of that being talked about. But what we're not talking about as much is, how are these AI tools impacting the entry-level job market? And again, I really think that computer science and the tech industry is just the first of the industries, because there's so much more training data, and the tools are built by people who understand the tech industry. But I really think that all of the industries, especially all the STEM and sort of knowledge work industries, are going to have this problem soon, where it's just going to become harder and harder to get entry-level jobs because the bar is higher. And a lot of those entry-level skills can be replaced with AI. And I think that that's really the big problem to solve. And we're trying to do it right now for computer science, but there's a lot of other fields that are going to have this problem soon.
All right. Well, I very much appreciate your time today. Thank you for joining us.
Yeah, thank you so much for having me. It's been a great conversation, and I always appreciate people thinking about these sort of issues. I think it's really important.
Thank you. Now, so listeners, we spoke with Tyler today about his journey as a nonprofit CEO for CodeDay, which is using data and creativity and 24-hour events, coding events, and mentorships to address some of the most critical problems in helping learners, and really just any learner, not just K-12 learner, but whether it's higher ed or someone who just wants to learn about how computer science works and how to solve problems. We explored all that with Tyler. And we hope today in this conversation sparked some idea that you can follow up on, some new insight. And until next time, we hope you have a fantastic day. Thank you for joining us here on Chalk and Code.
Thanks for tuning in. If today's conversation sparked new insights or challenged your thinking, we'd love to hear from you.
Visit flexion.us for more information and join us here next time on Chalk and Code.